Welcome to our today's class. Today we focus on program evaluation review techniques, simply called PERT charts. A PERT chart basically is a tool that we use to schedule, to analyze, and to do our projects so that they can be completed in good time. Now, when you talk about program evaluation review techniques, the PERT charts, they have two major things. There is what we call the activity. There is the activity. Activity is that event, that work that you need to do in order to accomplish your project. Usually we represent them with a straight line, and we give them the alphabet number capitals. If, for example, A was an activity that was going to take 3, so we shall write a straight line, we shall draw a straight line, and write there A equals to 3. An event basically marks the beginning and the very end of an activity. For example, if I was to begin A, I would say A, then I would map it like this. A, which is 3, and this is 2. So an event basically is at the very beginning and the very end. Usually we use numbers to capture them. Now, a general, when you're drawing a PERT chart, it's worth noting that there is always one single node that begins and one single node event that terminates. So the very beginning and the very end, in between anything can happen. But at the very beginning and the very end, they should begin with one event and terminate with one event. A general example, examples of PERT charts as shown here. Like this, it is beginning here, and the beginning point, there are 3 events. Sorry, there are 3 activities. It is terminating here, and at the termination point, there is only one activity. You can begin with one or more activity and terminate with one activity, or terminate with more activity as shown on this side. All you need to note is that at the very beginning and at the very end, there must be only one event. Now, how do we draw a PERT chart? There are 6 steps that I want to take you through in order to understand how to formulate a PERT chart. The first thing that you need to understand is that you need to determine the activities that you need to accomplish your project. For example, suppose you want to begin a small business. If you want to begin a business, then you would have the activities that precede the beginning of the business. You need to understand, for example, you need to get an office. You need to agree with the landlord. You need to purchase the furniture for that office. You need to secure security. You need to settle the rent after having signed a lease agreement. You need to set up the office, train your marketers, lodge, and so forth. Those are the activities. So you break down the project into viable activities. And then that is the first step. When you go to step 2, once the activities has been listed, then the second thing that you need to understand is how do they sequence? What do you need to do first before you do another? For example, there is no way you can sign a lease agreement until you have located where the site of the office will be. There is no way you can pay the rent when you have not signed a lease agreement with the person. There is no way you can go to somebody's premise to set up an office if you have not paid the rent. So you need to sequence what comes before the other. So when you are setting them, we use 2 ways. You can either put them the preceding activity. So like A, here we are saying A is not preceded by anything. So A is the beginning. Now, for you to do the other 3, these 3 events, then you need to have A needs to have been done. You need to have seen the office, so that You are signing a lease agreement with somebody you know. You are taking your furniture for in a room that you know. That needs to be done. This is, we call it sequencing. Number 3, once you have done the sequencing, then number 3 is then set up the construction. How do you construct? Like this one, you begin with an A there, number 1, and this is A. You terminate A. You write there 2. Now, when you look at after A, there are 3 activities that precede. So there is activity B, there is activity C, and there is activity D, which comes after A. Now, when you look at it now, B, there are 2 activities that come after B. So where B ends, you draw like that, you give it number 3, and then you begin the activity E there, and you begin the activity H there. Now you proceed. Now G begins after C has terminated. So once C has terminated, you bring number 4 there, and then G starts from that point. Now that is G, which is starting after A. Now H starts after E. H starts after E. So after E here, so this is number 5. So there I begin my my H. E, E, D, D, D. So this is F, sorry, this is F, and F. So this is H, which begins there. Now, when you do that, you realize that H, all these activities must be completed before H starts. So we start with activity D, which must be completed. So D must be completed. F must be completed. G must be completed, and H must be completed. When they are all completed, this put number 6 there. And then when they are completed, that is when J begins. Now, when J terminates, gives way to K. K. So this is number 7, and this is number 8. So K is the last event, and then you terminate. Now, there are 3 types of timings that we use to calculate what we call expected time of completion of an activity. We use what we call TO, that is optimistic time. That is the length of time taken to complete an event if nothing happens, no complication at all. TR is the realistic time, the time which we are likely to complete the event. And TP, which is P, TP is the pessimistic time, that should anything unforeseen difficulties arise, when what is the maximum possible you can allow. Then when that happens, you multiply the middle one by 4, and then you add and divide by 6, because already this is 1, this looks like there are 4, and this looks like 1. So these are 6, that's why we are dividing with 6 there. And having done that, then you can work out these timings. Like the first one, you take 1 plus 4 times 3, then plus 5. Now, when you do that, you divide by 6. So when you do that, you get 18, because it is 1 plus 12 plus 8, 18. So the first one will be 3. And you do the same for the others. If you multiply this one by 4, that gives by 4, that gives you 16. 16 plus 3 plus 5 is 24. 24 divided by 6, you get 4. And you continue filling like that. If you divide this, multiply this one by 4, it will give you 16 plus 8 is 24. So this one will be 4 also. You do the same and you fill up this gap. That's how we compute the expected time of completion. Once that has been done, then you go to step number 5. Step number 5 involves determining the earliest completion time. Now here, you need to draw that. Once you have drawn the diagram, you need to map these times in the diagram. Now, usually the first one, we usually denote it by 0. So here, for example, here if I have an event that begins here at 1, then I have an A there, then I have a 2 there, I have, let's say, a B there, a B here, then this is 3, B terminates. B terminates, I have a E, and here, let's say I have a C, here I have a D, and this D was going all the way like that. This, we were getting C here, here we were getting F. I'm not correct, I'm not wrong. Here we had E, E was giving way to H, and all these were completing, they were terminating at this point, which I'm calling this is 4, so this is 5. And so this one gave way to J, and J gave way to K. Now suppose A is 3, suppose B is 4, suppose this is 2, suppose this is 5, and suppose G is 8. Suppose this event here is 5. Suppose that this is 10, and that this is 3. This becomes 4. Let's finish K at 1. So this is 7. Now the earliest completion time here, T, at the very beginning is 0. Now the earliest completion time here you had 0 plus 3 to complete at 3. Then you had on this side the earliest completion time for this node is 3 plus 4, which is 7. You proceed, you had here the earliest completion time for this is 3 plus 2, which is 5. Proceed, and you had this here, the earliest completion time for this node is 7 plus 5, which is 12. Then you drop now down this way. Now when you are joining this is now where you need to take several consideration. There are 4 lines that lead to number 5. There is this line that goes like that. There's this line that goes straight, and there's this line that comes here. We pick the one with the highest time. When you use the upper road, you get 7, you get 3, plus this is 7, this is 12, then plus this, you get 15. And when you use the other road, you get 7, plus this, you get 17. Now when you use this other road, you get 3, 2, and 8, which gives you 13. This other route gives you 3 plus 5, which is 8. So the route that seems to give us the highest time is this one, which is passing like this. So it is giving us 17. 17. So we pick the longest route. We are picking the longest route because by the time J begins, all these other events must have completed. So we have to wait for the one which is taking the longest to complete. Now from there you come here, that ET for this, it will be equals to 17 plus 4, which gives you 21. And then the ET for this is simply 21 plus 1 to give you 22. Now, that is how we calculate the expected time going forward. Now, we need to understand that there is another measure which we call the latest completion time, latest allowable completion time, EL. Now, this, we work it backwards, and we usually pick. It can be specified by the manager. You can assume yourself that by the time you set up your business, you're giving yourself 2 weeks, 2 months, 7 weeks, 3 months, like that. So you set it yourself. So when you set it yourself, you come here. we come here. We assume that now that, let's assume, let's set it at the same time that you want to complete it in 22 weeks. This L, the latest allowable time should be L. Now, when we are working backwards, you take this, you subtract. Going forward was heading. You subtract, you get EL here. EL here is EL there is let's change the ink. EL there. EL. Our EL here is 22 minus 1, which is 21. Wanted to change the ink. So now we subtract here EL. EL here is 21 minus 4, giving us 17. Move backwards. Now you take 17 minus 3, so EL at this point will be 15 because, sorry, be 14 because 17 minus 3. Going that way is 2 lines there, so we have to be keen. So EL here is 17 minus this 8, giving us 9. EL for this one, the EL, where 2 lines come together. When we were going forward, we took the one with the highest. The route which has got the highest time, the highest number of weeks. When we are going forward, we take the one with the shortest. Now let's see. If you take 14 minus 5, 14 minus 5 gives you 9. But if you take 17 minus 10, it gives you 7. So we pick the shortest, that is 7. Proceed and come here. This is EL. EL, you are picking the one with the shortest time. So here we pick 9 minus 2. 9 minus 2 is 7. This root is 17 minus 9, giving us 8. 7 minus 4 gives us 3. So we pick the one with the shortest, 3. And then when you subtract this is obvious. It is EL is 0. Now, we want to calculate another time we call slack time. Slack time is the difference between slack time, SL, is the difference between EL, the latest allowable time, minus ET, the earliest completion time. So we do SL for each. So SL here, SL there will be, my SL will be, change the pen, my SL here will be 0. My SL here, the difference will be 0. My SL here, the difference will be 4. My SL here will be 0. My SL here will be 0. Sorry, will be 2. My SL here will be 0. My SL here will be 0. And SL will be 0. So from there, you now determine which is the critical path. Which is the critical path? The critical path is that path where your SL, which is equals to EL minus ET, is 0. Anywhere where it is 0, that is the critical path. That is the critical path. Back to our diagram. When you come back here, see where your critical path, your SL is 0. It begins from here. This is 0. So if you look at it, it begins this way. But from here, that root is 0. Now this is 0 here. So we go up. That is 0 also. This is 0. So we go straight punch like this, because this is not 0. And then we draw straight like that. So our critical path, critical our critical path will be 1 dash 2 dash 3 dash 5 dash 6 dash 7. That is the route that we call the critical path. Now, note that any event on the critical path cannot be delayed. If you delay an event which is on the critical path, so one, we note that any event on the critical path should not be delayed. What is the effect? If you delay any event on the critical path by 1, the effect is that it increases the number of weeks by 1. If you delay it by 2, it increases the time of completion by 2. However, any event that is not on the critical path can be delayed. For example, if you look at this H, when you follow this route, you have 2 excess weeks that you can delay H by 2 weeks so that you can add here 2. So that H, you can begin H on the, instead of completing it on the 14th week, you can delay H by 2 weeks so that you begin H when it is 2 weeks, when it is 3 weeks to this time. So that is possible. Events like this can be delayed by 4 weeks and they are not affecting. But any event that is on the critical path cannot be delayed. If you delay it by 2, you affect the time of completion by +2. If you increase by 2, that may have other effect. But if you delay it, it contributes that. And that makes the end of our class today. Thank you.